what we're going to do is, like I say, just kind of look at this. We start with circles in this chapter. And not all the formulas, when you look at your formula sheet, you're not going to find all those circle equations and those formulas on there. Those are polygons and polyhedrons and surface area and that sort of thing. So you're still going to have to know your circle formulas for this quiz. So when it comes to a circle, there are two basic ideas we got going on here. And a lot of people did kind of struggle with these a little bit. But I'll go ahead and first give myself a center point so I know where we're working from. Okay, so there's my circle. And our circle always has a radius. Ooh, I'm off a little bit. Hold on. I'm going to do a quick orientation. There we go. I don't have to do this very often, but once in a while it gets off just a little bit. So whenever you think you're drawing is like a quarter-inch below where you're actually touching the board, it gets kind of annoying after a while. All right, see if that helps. So we have two basic measurements in the circle. We have the radius and we have the diameter. And we know that the radius is half the diameter, right? So if this is the radius, if this length is n, this length is 2n. Okay, and that's my radius, and that's my diameter. And we know the circumference, which is the distance around the outside, is what formula? Pi times diameter. Now, remember when we're writing an answer for something like this, the pi goes last usually, and then the units. So because some people are putting the pi first. So if I get a number like 22 pi, I'm not going to write pi 22. I'm going to write 22 pi. That's just a generally accepted. And the area is pi r squared. Now, I still get people who mix those up. And really, that's just a matter of straight up memorization. Well, let me take that back. Memorization, yes, to know the formula, but also reading the problem to know which one you need to use. Because I get people mixing them up all the time. And we're asking for a length, maybe an arc length or something like that, and they use the area formula. Well, if an area formula doesn't work for length, and a length formula like circumference is not going to work for area. So if we're looking for sector area, we're going to have to use the area formula. So you really need to pay attention to what is the question asking, and then which formula is going to apply to this situation. And quite honestly, there's your life skill that you're getting from this right now. Okay? It's not very often, although it does happen that you have to find circumference and area of circles. This is not an uncommon thing. In the real world of home ownership and doing things and stuff like that, you work with circles a lot. Because you might need to find like cross-sectional area or something, or you're painting something, or you're working with something that's circular in shape and you want to work with it. Okay? It actually comes up more than you might think. But nonetheless, the more important skill that we're working on here is, okay, you've got a couple choices of formula. Do you know which one to choose? Can you make the right choice when it comes to this sort of formula so that you get the correct answer? Because there's going to be all sorts of situations in life where you're going to have to make choices about you've got two different things you could use and which one is the appropriate one. So discernment is important here. That's what we're kind of working on. So that's pretty simple, and for the most part, if I give you a radius, let's say I say the radius is 8 inches, then the circumference here would be 16 pi inches, and the area would be 64 pi inches squared. don't forget the units. You lose points on the quiz every time you don't use units properly. It's not huge deductions, but there are deductions. Half point here, half point there. You start losing half points on like 6, 7 different problems, and it starts really adding up quickly. And your grades just drop to a B instead of an A because you just forgot units. Okay? So watch that. Those are 2 very important formulas. The next thing we did was the sectors, and along with the arc length. And it's the same idea in both situations. Okay? Given the radius of a circle, and let's say, well, I don't know if I'm going to give you the radius. But, because the radius might be the thing that's unknown that we need to solve for. But in both these cases, what we're going to be either looking for is maybe just this length of the circle, right here, or maybe I want the area of this portion of the circle. But either way, we're looking for a part of the circle and not the whole circle, just a portion of it. And the way these things set up is always with a proportion. And that proportion always works out its angle, whatever this associated angle is, which I'm going to call theta right now, which is a nice Greek letter that we use for angles all the time. Okay? It's theta over 360 equals the part equals the part, which could be the arc length or sector area, okay, over the whole circle. And if it's arc length, that goes with circumference, or sector area, that goes with the area of the circle. So circumference is pi times diameter. We'll just do it that way, okay? And again, the choice we make here depends on what the question is asking and what we're given. But it's always, I have some part of a circle, part over whole equals part over whole. That's the way this proportion always sets up. And it's very straightforward once you set it up. But like I said, you got to pay attention to what it is you're looking for so that you choose the right formula down here for the whole. Or if they give you like the area of the circle, then you know you're working with area, and you got to be working with, and you got to stick with that area idea. So you got to kind of stick with that idea. Am I looking at lengths or am I looking at areas? Because they're different formulas, and you have to choose the right one. So if, for example, I said this radius is, I don't know, 9 centimeters. And this angle is 140 degrees. And I said, find the area of the sector. So find the area of the sector. So the first thing you're cueing in on when you see the problem is let's find the area. So we're going to work with the area formula, right? So immediately, as soon as I see find the area of the sector or find the sector, I think, okay, I'm cued in that I'm working with area. So this has to be pi r squared. That's 360. Those are my whole. The whole circle is 360. The whole circle is pi r squared. I know this angle is 140, and my sector area is my unknown. I'm going to have to calculate this value. Well, that's not so hard because the radius is 9. 9 squared is 81, so that's 81 pi. And now I can solve that pretty quickly by multiplying both sides by 81 pi, because the variable's up in the numerator here. So I can go ahead and solve that, and we're pretty much done. Now, our calculator is going to do that, and for the most part, I'm going to be okay in problems like this with decimal approximation. But don't forget the pi. I've got a couple people who on this last test set it all up perfectly like this, or in the last quiz, and then they just did 81 times 140 divided by 360. Okay, but you got to go 81 times 3.14 times 140 divided by 360. We set that up, 98.91. Then I look for my units, centimeters squared, because it's an area. It's an area, it's units squared. But again, these can come, anything can be unknown, and that's what kind of makes it interesting in this whole process, is that the unknown isn't always the arc length of the sector area. Maybe we'll do, and I'm going to say I want this arc length, or I'll tell you this arc length is 78. Sure, why not? And I'm going to tell you the circumference of the circle is 90. And we'll say the units is meters. Okay? What's the angle? Okay? You don't know. That's the unknown. But what do? We still set up the same proportion because it just means we're going to put our unknown in a different spot. Okay? So angle is unknown this time, so we'll put x, we'll call it x. You like x better. X over 360 equals the arc length over the circumference. And we just since the variable's up here, I could just multiply both sides by 360. 78 times 360 divided by 98. 98, or you mean just 90? Say 90, sorry. The angle's 312 degrees. Okay? Now, I didn't draw it well to scale, but you get the idea of the setup. So remember, in these problems, the unknown might be the angle. I might have these two, and the unknown might be down here. The only thing that's never unknown is the whole circle is 360 degrees. Okay? We're always going to know that 360, but my unknown might be here, it might be here, it might be down here. We just have to fill in the blanks in the right spots. You can't just get mechanical about this, say, okay, my unknown is always up here in the upper right-hand corner. Nope, it's not. And I got some people who try to force it into that model, and it's just not going to be successful. The unknown could be anywhere. All right. Now the one that really drives people crazy, the polygons. Regular polygons. Basically, anytime I have a regular polygon, that's not going to be an easy one to work with, but that's okay. Every regular polygon, and this, just breaking it down again, there's a center to every regular polygon. I'm kind of guessing where at this center here, but that breaks the polygon into a bunch of congruent isosceles triangles. That's probably pretty close, okay? All those triangles in a regular polygon are going to be congruent and isosceles. So, wait, your calculator? Okay. All right. So since it's an isosceles triangle, and again, these angles all have to be congruent. So it's easy to find the measure of these angles is just 360 divided by the number of triangles, which is the same as the number of sides. But then in order to solve this, just long story short, we have to break this down into a right triangle. And this right triangle always consists of three parts. The right angle is here. The right angle is between a half of a side. This is the apothem. And this is what we call a radius of the polygon. And this angle right here is, we know that this is 360 divided by the number of sides, each red curve there. Since it's half of that, The easiest way to do this is to say that this angle is 180 divided by the number of sides. Because half a central angle. Central angle is 360 divided by the number of sides, so 360 divided by 2n would be 180 divided by n. Okay? And so we always come down to having to solve that right triangle. Now, do not be confused. Sometimes the problem is very simple, and on the quiz, the first problem is the same as on the review. On the quiz, the first problem was very simple. People made it complicated. We gave you a polygon. We gave you the length of the apothem. We gave you the length of a side. You don't have to solve a triangle when we give you that information. Don't overcomplicate. Don't think every one of these problems means you have to solve triangles. Sometimes and oftentimes we'll give you at least one problem where all you have to do is basically plug numbers in the formula. Because the formula for area is pa divided by 2, half a dad, half your pa. Oh. Okay, perimeter times apothem divided by 2. Okay? And guess what? We have all the information we need here to find the perimeter. I know the apothem is given as 10. Since I've given that this side is 6 and there are 1, 2, 3, 4, 5, 6, 7 sides, the perimeter is 42. So this would be 42 times 10 over 2, or 210 centimeters squared. Okay? No triangles to solve there. So pay attention to the problem. Because one of the things that people did wrong on the quiz very frequently was you got a problem like this, and you went ahead and tried to solve triangles and overcomplicated it and messed it up. You spent way too much time on it than you should have. When all you had to do was pay attention to what was given, you were given enough information to go straight to the formula, basically. Yeah, you did have to figure out the perimeter, but that's, that's very minimal. But in a more difficult problem, like say, I have a regular nonagon with radius 5 centimeters. Okay? Find the area. So a nonagon. First we got to know what that means. How many sides in a nonagon? 9. Okay? So we know the radius is 5 centimeters. This is the radius side. I can figure out this angle very quickly. It's going to be 180 divided by 9 because there are 9 sides. So this angle is 20 degrees. I need to know the apothem here, and I need to know the half a side. I'm going to call that x. I need to know those two things. And that's where we set up our SOHCAHTOA. This is where we set up our trig. So if this is our angle, we can just work right through our functions, sine, cosine, and tangent, because we have SOHCAHTOA. Okay? So sine of the angle is the opposite over the hypotenuse. Cosine of the angle is the adjacent over the hypotenuse. Over 5, sorry. And I'm not going to need tangent because sine and cosine do everything I need. And I solve this very quickly. 5's in the denominator, so I multiply both sides by 5. Cancels 5 sine 20 equals x. Same thing over here. 5 cos 20 equals a. We put that into our calculator. 5 sine 20 is 1.71. 5 cos 20 is 4.70. Okay, that's my apothem. We're all set there. This is not my perimeter. This is half of the side. I then have to double this to find a whole side. So that would be, what, 3.42? that equals one whole side, and then it's times 9 sides because it's a nonagon. So 3.42 times 9, 30.78. So the perimeter is 30.78, and then I take perimeter times apothem divided by 2 times 4.7 divided by 2, 72.33. And its units is centimeters, so centimeters squared. And there's the area. So sometimes we have to solve the triangle, sometimes we don't. But it's the same triangle every time, but these numbers are going to be changing. When I say it's the same triangle, I mean it's always the apothem, the radius, and half a side. And this angle is always 180 divided by the number of sides. So the numbers are a moving target, depending on the number of sides of the polygon and the information we're given. But the elements that make up that triangle are always the same. So it's the apothem, half a side, and the hypotenuse is the radius of the polygon. So that's the polygon stuff that we were working on. And again, that basically takes us through that first quiz that we had before we got into polyhedrons. Now, the polyhedron formulas you've been given. Okay, make sure you understand the formulas on your sheet. Do not just ignore the sheet and say, well, I'll just pull that out at the time of the quiz. Because if you're not making yourself used to working with it, it's not going to be so helpful on the test. You want to use it regularly now. However, please do not be writing on or annotating your sheet or writing out what variables stand. It needs to be just a plain sheet at the time of the quiz. In fact, I'm thinking I may just recopy it and give you a blank one at the time of the quiz might be the best thing to do. So that's probably what I'm going to do now that I'm thinking about it. So, but use that sheet now. Get used to using that sheet to figure stuff out, because we've talked about all these different things we can do. Now, half the problem is figuring out what shape is my base most of the time. Is it a pyramid? Is it a prism? Okay. What formula applies to this situation? And again, just keeping in mind, it's pretty obvious in most part what's going on if you take the time to slow down and look. It's usually pretty clear the difference between a pyramid and a prism. Okay? No, I'm not doing the water thing again. We've been there. Okay? But look at the differences. A prism, the sides are rectangles. Okay? The bases are the non-rectangular sides. There are two bases that are identical in a prism, which is what makes the sides rectangles. Okay? So that's the prism. We use prism formulas with this. Volume is base area times height. Total surface area is perimeter of the base times the height plus 2 base areas. Because there are 2 base areas. It's on your sheet. Okay. Hey, Ben. Go sit in the hall for now.
Okay.
Just go sit out there. I'm not going to have you. Okay. This is a pyramid. Okay, pyramid. The sides are triangles. It comes to a point, a single point. It has 1 base, not 2. Volume is base area times the same height divided by 3. We demonstrated that. Do not divide by 3 for a prism. Do not mix up those formulas. You're given those formulas. Look at your sheet. Make sure you're using the right formula. Okay? When you're looking for volume, don't divide by 3 for a prism. Do for a pyramid. Surface area for this is a little bit different. It was perimeter of the base times the slant height divided by 2 plus 1 base area. And we didn't spend a lot of time talking about that because unlike in previous things with geometry, usually you're given the slant height. You usually don't have to calculate it using the Pythagorean theorem or anything like that. We usually make it pretty simple for you, in that you're given the slant height. So not too hard to figure out. But again, you got the slant height, remember, comes down the face of one side of the pyramid here. It's the hypotenuse of a right triangle that's made up of the apothem, the slant height, and the actual height. I don't think that really comes into play ever. But mixing up the formulas for these two is a huge issue. Every year I get people who mix up the formulas. So be very, very careful. The other thing is you got to take the time when you're solving these problems to kind of slow down and break it down. Don't try to just cram the whole solution into your calculator in one big step. Slow yourself down. Make sure that you are going through this. So let's just take a look at a couple quick examples. I can pull up these. And please remember, cones are basically prisms. Cones are basically pyramids. Cylinders are basically prisms. Your base is a circle. That's all. That's the only thing that's different. So instead of a polygon, your base is a circle. But the formulas still apply. So I don't know. What do you want to start with? Let's start with this. This is one that always gets people. First off, is that a pyramid or a prism? It is a prism. This is one that people often mix up because it's a right triangle prism. It's not a regular polygon base, it's a right triangle base. Okay? But my base is the right triangle here. Okay? That's my base. And there's a second one matching it, which is a key sign of a prism. We're dealing with this sort of thing. There's a second base matching it right over here. Now, yeah, it'd be easier to see if this is always filled in, which is why I tell you when you're working on a test or a worksheet like this, shade in your base, and it makes your project easier to see. Now, if I want to find both the surface area and the volume of this, there are a couple things we're going to need to know. First off, the height of the triangle versus the height of the prism. There are two different height measurements here. That is confusing. Okay? Because I'm finding the area of the base. I'll say this is 5 inches, 12 inches, and 13 inches here. And I'm going to say that this distance is 15 inches. Okay? The height of the base is the 12 inches here. That's for the base times height divided by 2 to get the triangle. The height of the prism is the distance between the bases. So I have two different heights here. So let's just start with surface area. Surface area is the perimeter of the base times the height plus 2 base areas, right? Is that the way the formula is written on your sheet? I may have switched it. Like the 2b plus ph? Yeah. Okay. Fine. Same thing. It is, but I want to do it in the same order they gave you there. Capital B always stands for base area, okay? So notation thing, capital B always stands for base area. So what is my base area? My base is a triangle. So I need to know, how do I find the area of a triangle? Base times height divided by 2, right? That's old school. We know that one from a long time ago. So in this case, it's a right triangle, which means the base and height are the 2 legs. So this base area, I'm going to do a little side problem here, is 12 times 5 divided by 2, or 30 inches squared. Right? Do that off to the side. Calculate that number separately. What's the perimeter of my base? The perimeter of my base is the distance around the outside of the base? Well, 12 plus 5 plus 13, that's 30 inches. Coincidence, by the way, that those numbers are the same. They're different units, so they're actually different values. Okay? But 12 plus 13 plus 5 is 30 inches. And the height of the prism, this h is the height of the prism, not the height this way, the height being the distance between the bases, right, is 15 inches. So kind of do your calculations off to the side for the numbers that are going to go in the formula before you plug them in the formula. Don't try to do it all at once. Once you've got those numbers, then you can say surface area is 2 times 30 plus 30 times 15, or 60 plus 450, which would be 510, and it's inches squared. That's an area. All right? Because once I've got the numbers kind of figured out off to the side, it's easy to plug them in the formula. But the mistake that most students make when they're working with this, the single biggest error I see constantly, is people trying to push right into the formula without doing this little bit of work off to the side first. Save yourself some grief, do little problems, and then use the solutions to the little problems to get the big ones. Get the values you need. Okay? If I was going for the volume of this, volume we know is base area times height. By the way, we've got those numbers already. So that'd be 30 times 15, or 450 inches cubed. And volume is in units cubed. Surface area is in inches squared, because it's an area, inches squared. Let's do a pyramid. We'll make my pyramid a cone. Okay? So 8 centimeters, 15 centimeters, and 17 centimeters are those measurements. Find the surface area and the volume of this cone. Well, again, surface. Now, you do have special formulas on your sheet, I believe, for cones, right? Let me look. Surface area of a cone, pi r squared plus pi r L. Okay? Now, realize base area plus circumference, perimeter of the base times the slant height divided by 2. That's a special formula that kind of simplifies it for you, but go ahead and use the formula. What is the only thing we need to know? I need to know R and L. Well, what am I given? There's R, there's L. There's really nothing to do here, is there? Except plug the numbers in the formula. So pi times 8 squared plus pi times 8 times 17. So that's 64 pi plus 8 times 17. That's 80 plus 56, 136.
Was 17 centimeters given?
Yes. If not, we'd use Pythagorean theorem to find it. Okay? If they didn't give it to us, it's a right triangle Pythagorean theorem, right? So 8 times 17, I did this, 136, yes. Now, we could leave this in terms of pi, and I get exactly 200 pi centimeters squared is my surface area. Or you could multiply that out and get 618 centimeters squared. Or 628, excuse me. Not 618, 628. Okay? Volume equals pi r squared h over 3, right? Is that what the formula is on your sheet for volume of a cone? Is there a volume of a cone
Yeah. Wait, it just says volume of a pyramid slash count, which is the H of 3.
Okay. Right. Well, okay, so it says, so they didn't give you a special formula. That's fine. Base area times height over 3. Well, what is the base? The base of the circle, right? So the base area is pi r squared. Now, what's my h going to be here? H is different from L. H is the height, L is the slant height. What is h in this picture? Height is 15, radius is 8, so that's pi times 8 squared times 15 over 3. Do not get your order of operations off here. Do not do 8 times 15 and then square it. Okay, 8 is the only number being squared. So 64 times 15 times 15 times 15, let's try that again, divided by 3 is 320 pi. And it'd be centimeters cubed. It all works out. So being able, the big thing here is being able to use formulas. If you can't pick it out yet, the real theme of this chapter, while we are using area and volume and surface area and circle sector area and arc length, those are all vehicles we're learning to teach a skill. What is the real skill we're working on here? How to use a formula, right? That's the big skill that underlies this entire unit. That's what ties it all together. And like I said, well, you're probably not going to have to spend a lot of time finding surface area and volume of things in real life. You are going to, if you ever do taxes or anything like that, or most jobs involve some sort of math where you have to use some sort of formulas. And so the ability to use a formula and to adapt a formula and to deal with a formula when the unknown isn't necessarily where we expect it to be, but where it's somewhere else, like we do with the arc length and the sector problems, that's a pretty big skill. Which is why I give you the formulas for the second part of this chapter, because I don't want you to spend tons and tons of time memorizing formulas. I mean, really, the only formulas you need to have memorized are area of a circle, circumference of a circle, which are kind of given on that sheet if you pay attention, by the way. Pi r squared is right there on the formula sheet, isn't it? That's area of a circle. Circumference isn't given. That's pi times diameter. You'll have to know that one. But once you've got those down, there's not a whole lot to remember as far as formulas go. Okay? So hopefully this just kind of reteaching through the entire unit. I didn't do spheres, but they're just other formulas. That's pretty simple. Is there anything that you have a question on? We've got about 5-6 minutes left here. This is a great opportunity for you to ask about any type of formula, any type of sample problem you might want to go over. If there's one you saw on the review sheet that you already have questions on that you want me to look at right now would be a great time to ask. We'll go over the entire review sheet tomorrow, but I'm happy to do it a second time. That wasn't the question. The question was, is there anything that you want me specifically to go over right now as an example? It's a great opportunity. Okay. Make sure you get that review sheet done before class tomorrow. And don't just write the answers on it that you copy off the back of the review sheet. Actually work through every problem, because you know the test is going to look just like it. And then come to class ready to go over it and solve all your problems so that when the actual test comes on Thursday, you can really crank through it. All right, in the last few minutes, and I will just be probably doing some checking in of people's sheets who are not all checked in yet.